All right, it's 4:30. Let's get started. So you're almost done for the day. Thanks for coming to the last one. My name's Pete Kennedy, and we've been doing some trail prioritization work for performing maintenance on trails in Pisgah National Forest at the school I teach at. I'm the GIS instructor at AB Tech in Asheville. Been there for 11 years. I taught at Greenville Tech before that and at Haywood Community College before that. We've got a small GIS certificate there. There's 3 GIS classes. You can take them online. If anyone would like to take a GIS class, you can get in touch with me. The abstract of this didn't get into the app, so I threw it on this slide. Just so you could have it if you want to get the PowerPoint. Essentially, the basis for what we did is that the United States Forest Service funds for maintaining trails has dwindled drastically over the years as use has gone up tremendously. There's lots of national forest around Asheville. As the population explodes, more and more people are out using the trails. So it's been difficult to keep the trails maintained properly. So a lot of volunteer groups in the area have stepped up to start maintaining trails. Pisgah Area Sorba is a mountain biking group. They've probably done the most. The Backcountry Horsemen and Horsewomen of Pisgah also have. The Pisgah Conservancy is a newer group that has also been stepping up to work with volunteer groups to start to help to maintain these trail systems that the Forest Service just really can't keep up with anymore. So at AB Tech, we've had some GIS students and myself and my department chair work with these trail advocacy groups to try to prioritize trail maintenance, to try to just get the most needy trails maintained the quickest. So what we're trying to look at is the steepest pitch slope that are likely to need maintenance. So this is a definite work in progress. I've been trying to have other people do as much of the work as I can. I'm the one presenting it today, but I've been trying to get my students to do most of it, my department chair to do as much as possible. So it all started a couple years after I had been teaching at AB Tech. A student did a little slope analysis like this, and I thought it was really cool. I started hiking and mountain biking in the National Forest in 1989, around there, so I've got a lot of invested interest in the trails. I like to spend a lot of time on them. And so when my student did the little analysis, I thought it was really cool. And it was probably 9 years ago, but then he went on and I never got back to it. But I thought it was so neat that in my introductory class, almost every single semester, I use it as an example of what you can do with GIS. So my students that come in that don't know much about GIS, as I'm trying to teach them a little bit on the first day of the semester, I say, well, you can take trails data and you can overlay it on slope data and you can determine the steepest trail, and then you can maybe look at which of the steepest trails are on a certain type of soil that might erode more than other soils, and then you can maybe see which ones of those are the closest to a high-quality trout stream, something like that. And so that's just an example I've been using in my class in the first day ever since my student did this 9 years ago or so. And so last fall, a student came up to me after that first class and said, hey, I'm a member of Sorba. I really want to do this. And so he started spearheading it. So I let him do it, and I wasn't sure how we were going to do it at the time. I remembered a student had done it before. We started looking at some different ways to do it, and eventually we came up with a process that works pretty well. So these are some of the collaborators. David Bird is my student. He's retired and moved to Asheville, but he's a big mountain biker, and he is very interested in it. Jerry Davis is at the San Francisco State University. He wrote part of the program that calculates the slope. I borrowed it from the web. He was nice enough to talk with me about it. He actually grew up in North Georgia. He's in San Francisco now, but he's very familiar with the trails just by coincidence. Brenda Mcfarlane is my department chair. She did some of the database work. Mark Steerwalt, David Wax, they're both with the Forest Service, Sorba, and the Pisgah Conservancy. They provided a lot of input and, I guess, direction, you could say. They keep changing the direction. They've provided many directions. And then myself. I'll put myself at the bottom because, like I said, I've tried to let other people do most of the work. All right, so Pisgah National Forest is a big national forest, 500,000 acres in western North Carolina. There's 800 plus miles of national forest. It's managed as 3 districts, the Pisgah Ranger District, Grandfather, and Appalachian. There's other national forests in western North Carolina, like the Nantahala National Forest farther west. So there's a lot of national forest in western North Carolina. This is a map that gives you a little idea of the protected lands in western North Carolina. I actually included other lands other than just national forests because this methodology, I think, will apply well to any trail systems in western North Carolina and beyond. So let's see if my mouse works here. Can y'all see my mouse? I guess I can just walk over here. Asheville is here. This area is the Pisgah Ranger District. This is the Great Smoky Mountain National Park, and the area up the Tennessee border is the Appalachian District, and up this way is the Grandfather District. That's South Mountain State Park, Green River Game Lands, DuPont Recreational Forest, Toxaway State Park. So all the conserved public lands are shown there, or most of them. So most of our work to start, just to kind of prototype this, has been in the Pisgah Ranger District here. And this little area is called Bent Creek. It's an experimental forest that's closest to Asheville and heavily used. So we've been slowly trying to move out in the Pisgah Ranger District primarily to start. All right, so why are we trying to prioritize trail maintenance? They need to be maintained to remain sustainable. So what's a sustainable trail? Well, there's a lot you can read on it, but essentially a trail that doesn't erode into streams, that water doesn't pool on. It's built and managed in a way that it doesn't need a ton of maintenance. So a sustainable trail should not need a lot of maintenance. We're trying to prioritize the trail maintenance because we need to better allocate resources. We don't have a ton of money. We use volunteers. So if we could better pinpoint where to go, it will help us to better use our resources. Those of us who spend a lot of time on the trails, we know the trails that need to be maintained, and most of the people in the volunteer groups know pretty well too. But this gives us a way to have some data to show the Forest Service and try to better understand what we're dealing with. All right, so these again are those groups: Pisgah Area Sorba, Backcountry Horsemen and Women of Pisgah, the Conservancy. I forgot to mention the Northwest North Carolina Mountain Bike Alliance. They're actually the Grandfather District up to the northeast of Asheville. I've talked to them about this. They'd love to implement this a little bit and learn more about their trail system. We do have a brand new Adopt a Trail program that Pisgah Area Sorba has just launched that is having local businesses adopt trails too. So that's a pretty neat new program. We've got a lot of passionate people around Asheville trying to better maintain the trails. I've got a few pictures of the trail systems before I show you the process. You can see the mud on the trail there. This is a pretty good example of a trail that's eroding pretty badly. It's kind of hard to tell the slope of it from the picture, but you can see the roots and kind of where the runoff goes, and they've already started a little bit of trail maintenance there. And this is real common to see in the forest, although this is not on a steep slope. This is the kind of thing they try to help alleviate. Tools of the trade, things we use to maintain trails. I thought this was a pretty good example, and all of these pictures are right off the Sorba Facebook page for full credit. But you can see this trail. What they've done is they've used what they call rock armor, essentially rocks, to better define the trail, and then they filled in the areas to try to guide people to stay on certain parts of the trail. More rock armor on the left there, and they even build some bridges occasionally if they need to for runoff. And I just put this in. It can be a lot of work to alleviate some of the problems with the kind of work we do with the trail maintenance. So these are the United States Forest Service trail design parameters, and this is what we started to try to use our data to better understand if the existing trail system, how it relates to these existing design parameters. So when we first started the project, I thought, well, we're going to try to find all the trails over a certain steepness that are on a certain type soil close to a certain type stream. And that's what I thought we were going to do. And then when we started talking to the Forest Service, they were like, we've got these design parameters. Can you tell us how much of our trails fit into these design parameters? And so that is what we have done so far. Spoiler alert, they don't fall into these design parameters at all. They wrote these in, I think, 1994. And all the trails in the Pisgah Ranger District that I was using before 1994 were already there when they came up with this, pretty much. Probably 90% of them were already there. So trying to see how much they can get into these design parameters. So there's a target grade. That's the average across the whole trail. The short pitch max is the steepest grade that it can be, and it should only be for a distance of 200 feet or less. And then there's the maximum pitch density, and that's the percentage of the length of the trail that exceeds the target grade but is equal to or less than the steepest pitch. So with the trails, we've got different uses. Trails in Pisgah National Forest, and this is kind of common for trail systems, you can have different managed uses for who can use it. So in Pisgah National Forest, you can have some trails that you can only hike on. No bikes, no horses. You have some trails that you can hike and ride a bike on, but no horses. You have some that you can hike, bike, and ride a horse on. And then you have some that you can hike and ride a horse on, but no bikes. So those are the designed uses. You don't see hike, bike, horse, or equestrian in here because they manage it to the bike standard if it's hike, bike, equestrian. So these are the Forest Service guidelines that we tried to look at. All right, so to the tool. We essentially used a model from the San Francisco State University. We downloaded the model. It's got some sample data. It uses a couple tools everybody gets with ArcGIS. It dumps into a program that Jerry Davis wrote to calculate the slope, and you run it through the model. So the model has to be added to Arc Toolbox. You substitute your data for the sample data, and then we summarize the results in Access because it's a little bit easier. So here's the model. You need a DEM and you need a line shapefile, and they actually have to be shapefiles because of the way the model is written. It's kind of a lot of stuff's hard coded in it. It's not a super elegant, sexy kind of process. It's a little bit clunky. If anybody wants to write a web app to do all this stuff, that would be awesome. Vicki or Gene, you guys at the county, somebody maybe. You take the DEM and you convert it to a 10, a triangulated irregular network. The 10s are better at calculating slope because of the faces on the polygons of a 10. From there, you create a 3D shapefile by smashing the line work with the 10 to get, so your line work that has an X and a Z, or an X and a Y, gets a Z. So then you have elevations at the end of each line. And the magic happens here in this program. Essentially, we use the Pythagorean theorem to determine the slope of a triangle. And you get with the Z values between 2 points, you subtract the Z values, and you get the distance using the Pythagorean theorem between those 2 points, and you calculate slope there. So in one of Dave Michelson's presentations yesterday, he was talking about the programmer that performs the magic for the task or the job that you need to perform. This is where that happens in this project. So this is a map one of my students made, and I just thought I would run the model for you and let you see it. Got a few more minutes. After you run the model, you get a new shapefile that has slope on all these line segments. And we export that to CSV, load it into Access, and run some queries on it to end up with our report. The ArcGIS is not a great tool for doing a report like this. So let's see if I can find this thing. All right, so here's Bent Creek. Turn off the contours. And here's the model. Maybe I'll zoom in a little bit. What's that? Oh. Wonder how that works. Maybe we won't see this today. All right. So this is Bent Creek here, and it takes the model about a minute to run. So you've got the Bent Creek DEM and the trail shapefile. They're going to essentially make a 3D shapefile, throw it into that program to generate slope, and we'll see what that does. Oh, problem. I took care of that before, though, so luckily, I was messing with it earlier. So you're not going to get to see this thing bubble through all the colors, but I've got the data. Has anybody ever run a model before? I've probably seen that happen, right? Okay, so what happens is it generates a 10, maybe. It looks like this, and it fails if you try to do it on a really big area, and it comes up with from that it generated this trail slope layer here. So if we look real quickly here at the original Bent Creek Trails layer and we open the attribute table, you'll see that there's 28 lines in the original Bent Creek Trails layer. If we open this new layer that got created, there's 13,123 line segments. So all those little line segments have slope. So everywhere slope changed became a new line segment. And you can see the line slope there in percent of each one. It adds these IDs to it, so you can actually add the trail name back in by joining the tables back together, which I didn't do. And so let's zoom in a little bit, and we'll look at what it looks like. I went on and symbolized it based on slope. So this is 0 to 10%, 10% to 20%, and greater than 20%. You can see the slope along the line there. And real quickly, let's look at the access database to show you kind of the report that runs. Essentially, we do several queries. We get the weighted average, do a summary, the average for the entire trail. Then we're essentially pulling out those Forest Service design specifications using access. It's a little bit easier to do it in there. And this is what our report looks like. You run the report, it pulls data from these queries, and you can put in a trail name like Sleepy Gap, which is right where I was zoomed into. And it pulls up the information for Sleepy Gap. Sleepy Gap has a hike and a hike-bike section. It shows you the average. This is the average. So the average has to be 10 to 12 or 3 to 12, 10 or 12%, depending on the use. So both of these are over the average. The short pitch max, they're both over what they should be. And this is the percent of the trail that is in between your average grade and what should be the short pitch max. So this one is actually less. I think it was the 20% was is what it could be, 20% of the trail. And the other one is way over as well. So this report's what we use to try to summarize it based on those Forest Service design specs. We haven't showed it to them since we got this far, but so I imagine when we show it to them, they're going to ask us to do it a different way or give us something different. I still like the idea of just looking for all the trails that are, say, over 8% on a certain type soil within the distance of a high-quality trout stream. I think that's as much use as anything. So we'll see if I can get these other people to keep working on this, and maybe I'll come present it again. Yes, Jason. Yeah, I have not been out yet. I mean, I have. It does feel steeper than that, doesn't it? We haven't been out to actually measure slope in the field. No, but Sleepy Gap's pretty steep. That's a good point. We need to go check. And I'm trying to think of which DEM I used. I think I used a 10-meter DEM from the LiDAR for this one. And we broke out the Pisgah Ranger District into different chunks. We tried to run it on the whole thing, and it failed miserably because the 10, I think you can do 15,000 points in a 10 before it starts choking my computer. Yes?
Isn't there new LiDAR data coming out that might be
Yeah. I went to that presentation this morning. I think they said the end of March, but they've been saying that for a while, I think. So it'd be interesting to use that. It's going to be really big data. We'll see if we can do that for all of Bent Creek. I did some canopy studies for the Forest Service for Bent Creek with the old LiDAR data several years ago, for a project outside of school. And I had to break Bent Creek down into 4 chunks to do that canopy study because the computers I was using couldn't process. It was like 22 million points or something in Bent Creek with the old data. So, yes, either one. You first. The 2D shapefiles are Forest Service data. It was originally GPS'd. Yeah, you can probably see the trails from it. They're all pretty accurate. I do a lot of trail mapping outside of school as well, and the trails are pretty good. Yeah.
How recent would you say the elevation is?
The elevation data is from the original LiDAR work. So when was that done? 2010. So it's been a while.
So if there's been maintenance work done since then, you can't tell that?
No, I don't think we see the maintenance work on the actual elevation data. I don't think you see it in that. Yes.
So the 10 will give you slope polygon or slope areas. A lot of them will be shorter than what the Forest Service is specifying as far as what they want for their average. Like, they don't want a steep slope over 200 feet, right? You're saying something like that. Are you dissolving these sort of slope areas?
We do a weighted average across them. Yeah, that's how we take care of that. We don't dissolve out all those little ones. Yes. Oh, Holly, our Forest Service employee. Oh, good. You do already? Okay. I didn't see you hiding back there. Were you talking? She's the GIS person for the Forest Service. Any other questions? Yes. It creates points from the vertexes on every, let's see if I can get this to work again. If we zoom into this thing, you can see, let me turn on so you see it cut across let me make it, I don't work well without a mouse. Hopefully I can symbolize this a little differently. Properties for selected and do it a little bit smaller. It's not really showing it that well. You can see it at least in a couple of places, like that chunk right there. See, that gets a slope from that triangle, and so 2 points are generated from those 2 vertexes. And it generates it for that little chunk of line. And sometimes you'll see like this, it's the same color going across those two, and that's just based on the symbology. Those two fall within that class. That's just based on how I've symbolized it. So when you see it cross across two. So it's a pretty neat tool. The first thing I did was I just generated a slope raster file, and I converted it to polygons, and then I tried to apply that. Then I tried to do a spatial join, or I do it. Somehow I stuck the slope from the raster data onto that little chunk of line. But with that, you don't know what direction the trail is going across the slope. So the trail could be going straight up or straight across, and you can't tell from that. So the 10 allows you to factor in how it's going across the slope. Any other questions? All right, thanks.